Consider this photograph. At first glance, it might appear normal, but in fact, it's been manipulated. The car was spliced in from a different image. In this work, our aim is to try to detect images that have been spliced and also to localize which parts were spliced in. If there were some way to determine the source of each image patch, this task would be very easy. What's more, if we had the EXIF metadata of these two source images, we would see that the spliced regions came from cameras with very different properties. The photo of a car has a different camera make and model, different image dimensions, different focal length, and different compression scheme. Of course, we don't usually have access to the source images or their metadata, but we can still capture this idea by learning to analyze the content of an input image. In this work, we propose a model that learns to detect EXIF metadata inconsistencies. We train our model on a large dataset of unmanipulated web images without using any labeled images. Our model takes two patches from two random images and learns to predict which attributes of their EXIF metadata are different and are the same. When we evaluate the accuracy for our individual EXIF tags, we see that the attributes related to the imaging pipeline are highly predictable, while other attributes, like the date the photos were taken, perform no better than chance. Once we have trained this model, we can use it to detect spliced images, like this one. We take pairs of image patches and ask our network how consistent their metadata is. From these pairwise comparisons, we create an affinity matrix. We can then use a mode-seeking algorithm, mean shift, to compute the overall consistency of the image. Or we can use spectral clustering to visualize the spliced region. Here are some results that our model produced. On natural images, our model detects significantly less inconsistency. There are also still many cases when our model makes mistakes. In overexposed and underexposed images, our model has trouble predicting the consistency of the metadata. Also, when the image content is copied and moved, our model sometimes fails to detect any metadata inconsistency. Thank you for your time. For quantitative results, please refer to our paper.